Theories about mountain building we've already seen Harold Jeffries series, Taylor interpretation, Wagner, and geosyncline concept and modern PTT theory we'll see today. So the geosynclines, the idea is to explain how the fold mountains must have formed. Hall and Dana, they define geosynclines as massive elongated depressions resembling very large valleys. So the length will be very much high when compared to the width or the depth. So these are relatively shallow, relatively because the width and depth may be 2 to 3 kilometers, which may be huge, but compared to length, which may be 2 to 3,000 kilometers, these are very small in comparison. Therefore, they are relatively shallow. And also, Hall and Dana mentioned that geosynclines had mobile sinking floors, that is ability to become deeper when due to the weight of the accumulated sediments. So initially this is the floor, and due to the sediments from the erosion and due to the weight of the sediments, the floor will sink and become deeper and deeper. So this is a mobile sinking floor. Next we have Hogg, who tried to map the presence of ancient geosynclines using the paleographic map of the world. And next, according to events and later according to J.S. states, we have according to them, geosynclines could be at margins of the continent or interiors of the continent. These are the margin of the continent, this is the ocean, this is the continent, this is geosyncline. These are the interior, we have continents on the both sides and geosyncline in between. Next, the types of geosynclines according to style, there are two types: my geosyncline and yo geosyncline. These are smaller, these are larger, these are shallower, these are deeper, these are located more towards land, these are located towards sea. Since these are towards the land, their deposits are from the land. Here deep water sediments called fly ash will be there. The deposits will be coarser and more quartz content will be there. Here sediments of volcanic origin can also be there, like ophiolite. So here we can see these are myogeosyncline, which is smaller and shallower. Here we have the eugeosyncline, which is deeper. This is towards the ocean, this is towards the land. We have the coarse and quartz material here. We have the fly ash and ophiolite here. In between these two, there is a landmass called as genticline. Next, we have the Koshat, who gave monogeosyncline, polygeosyncline, and mesogeosyncline. Monogeosyncline is small. This is not as deep. It is only capable of one upliftment. This is the keyword here. And polygeosyncline is a larger and relatively deeper, and this can be uplifted more than once. So poly means more than once it can be uplifted. And mesogeosyncline, these are the largest, and these are very deep floors. Floors can be as deep as the oceanic basalt floor. So monogeosyncline example is Appalachians. Poly, we have Rockies and Urals. Mesogeosyncline examples are Mediterranean Sea and Tethys Sea. Next, the formation of geosynclines according to Arthur Holmes. The main reason for formation is due to the internal forces and the effect of convection currents that are resulting from these internal forces. So the first possibility is the rising and converging currents. Here the rising and converging currents, they will thin the crust, so the crustal thinning will happen. This thick here, this will be thin. Due to thinning, it will sag and bend, and it will turn into a geosyncline, sagging and bending to form a geosyncline. So this is one possibility. A second possibility, if there is a converging and descending convection currents, there will be again two possibilities here. First one is due to the converging and descending convection current, it will force the bending due to the mantle pull beneath. So this force will pull it, so it will sag over here and it will become geosyncline. Or it may be possible that the mantle rocks, they will get denser and denser, and because of the forces downward and towards its own weight, this will go down, and because of the vacuum left here and the forces acting here, it will bend like a geosyncline. So these are the expressions given by the Arthur Holmes. Next, we have the formation of the geosynclines into the fold mountains. So this explains only how the geosynclines are forming. Now we are seeing how geosynclines will turn into fold mountains. So as we know, geosynclines are massive depressions that accumulate sediments. Whenever there is a force applied on the sediments, they will be folded upwards, and the sediments will be squashed and compressed to form long linear mountain chains, which will be called as the fold mountains. So Holland, Dana, Haag, Style, and Schuchert, we have seen earlier, they all only explain the nature of the geosyncline, whereas Kober was the first to suggest a process of upliftment, how geosyncline turns into the fold mountains. So there are 5 stages in the upliftment according to the Kober. Last stage is the death stage. The geosyncline stage is the first stage, which has sedimentation and sinking floor. This is the Holland Dana type, who only described what the geosyncline look like. Next, we have the lithification stage, where sediments accumulate and they slowly convert into rocks. We have the tectogenesis stage, where metamorphism happens and the rock structures are actually formed. So the rock features and structures are formed here. For example, bedding plains, internal lifts and faults. There can be volcanism too, but Kober does not explain how. Next, we have the orogenesis stage, which is the actual upliftment of fault mountains from the geosyncline sediments. So this is a geosyncline stage where we have sediments coming into the depression. Next, we have the lithification stage where the rock formation starts. We have the tectogenesis stage. The ash color rock turns into the purple color actual rock structure. Next, we have the orogenesis stage where the forces are forcing the sediments to fold and form into the fault mountains. So according to Kober in the origin stage, there are two possibilities depending on the nature of the compressive forces. If the forces are moderate, not the complete geosyncline will uplift, only margins of the geosyncline will uplift, and the central part called medial mass will be left over. So in between two parallel ranges, so the moderate forces are acting on these two directions. Only the margins will uplift, and the median mass will be left over. This median mass can be uplifted plateau like Tibet or Iran or Turkey plateau. It can be depression like Great Basin USA. It can be plain like Hungarian plain in between Carpathians. But if the compressive forces are very strong, the entire geosyncline will be uplifted and a series of parallel ranges will be formed. The forces are strong, therefore the parallel ranges are formed here. So these are the two possibilities. And the last stage is glyptogenesis, which is basically death of the fault mountains. So the erosion leaves behind only low-lying residual hills. Examples are Urals, Aravallis, Eastern Ghats, and Joran Mountains. So what are the Kober's mistakes? He did two mistakes. First, he explained syncline compression due to the thermal contraction, which is happening because of the earth cooling. The compressive forces are due to the progressive cooling and contraction. Therefore, he was a thermal contractionist. And also, according to him, continents are permanent and do not move. So he was an immobilist also. So he was similar to Harold Jeffrey, and compare him with the Wegener, who was a revolutionary. He was a displacement theorist. So these are the two mistakes. Therefore, this entire theory is wrong and discredited. Now, the modern theory of plate tectonics, it explains the origin of fault mountains. As fault mountains are the integral to the plate dynamism, so they are related to how the plates dynamically change, and these are associated with the convergent plate boundaries. So there can be three types: OO, OC, and CC. So the sediments uplifted are of ocean accretion prism, and they are associated with collision and subductions of the plates. So first we have the OO type, where the subducting ocean plate is going down, and this basalt comes up as the andesite and forms the archipelago. We have the forearc zone, because of scraping and plastering. We have the accretion prism forming here. This is a forearc zone, this is a backarc zone. In the backarc zone we have the marginal sea, this is the continent. So this is the marginal sea. So here this is the first stage in sediment accumulation. It accumulates here as a accretion prism. It will be smaller, and no proper fault mountains will be formed. Only the archipelago or island will form. The features are we seen: trench, archipelago, accretion prism, marginal sea, front arc, and back arc zones. So since this is the andesitic eruptions, it will be violent earthquakes and volcanoes. Coming to the OC type convergence, here this ocean is finished, and we have the continent here, which is coming over here. Since there is the andesitic archipelago and other sediments of andesitic nature, they will turn into granitic batholith here, and the basaltic ocean floor is subducting. It will form as the andesitic here. All these melange will form into the andesite fault mountains. So melange is uplifted into Andes fault type mountains. We have seen sedimentary Andes type is there. Volcanic mountains have seen there because of the basalt flowing as andesite, and batholic cores due to andesitic archipelago and other andesitic turning into granitic batholic. Since these are andesitic eruptions, these are violent and earthquakes and volcanoes. Next CC type, we have the under thrusting but no subduction, because continental material does not subduct. Since there is no subduction, there will be no volcano, and there will be a phenomenon called doubling of crust, where the crust doubles and becomes very tall. Since there are large and compressive forces and enormous sediments, there will be formation of the very high Himalayan type fault mountains. Also, the complex features will be formed because of very high forces and underriding of places and doubling of crust. These are simple fold, but if the forces are too strong, there will be isoclinal, recumbent, and nappes will also form. Since there is no subduction, there will be no volcano, but the earthquakes will be there.